Hi, I'm Jim Anderton, Director of Content here at Engineering.com. Is the new aluminum the death of automotive steel? A lot has been written about Ford's switch to sheet aluminum for the 2015 F-150 light truck line, and contrary to the expectations of many, it's been a notable success. Aluminum has been used in automotive applications since the 1920s, but forming aluminum sheet into car bodies has always been expensive, difficult, and as a result, it's been limited to high-cost, low-volume vehicles like sports cars and heavy trucks. Why? Because aluminum sheet is notoriously difficult to form and fasten compared to sheet steel. In stamping, springback is an issue. Aluminum's property of quick passivation in air leaves an oxide layer that complicates many welding and finishing processes. Most of all, however, it's been about a lack of experience. Forming and spot welding a sheet steel into unitized body and frame construction really took off in the 1960s. In over half a century, any manufacturing process matures to the point where it's a low-risk choice when developing new products. But this is changing rapidly. Now, the mass media claims the shift to aluminum is driven by the need to reduce weight and improve fuel efficiency, but that's not entirely the case. High-strength, low-alloy steels have allowed significant downgauging of steel sheet and a lot of weight reduction, plus they're easy to form and fasten with conventional technologies. Modern aluminum automotive body and white production, however, is hybrid, and I don't mean hybrid in the sense of powertrains, but hybrid in the sense that steel is still used in critical applications, specifically to support the passenger compartment for crashworthiness reasons. Now, Atlanta-based Novelis has introduced what the firm calls its Advans 7000 series aluminum sheet that they claim is 2 to 3 times stronger than current high-volume sheet aluminum alloys. The new alloys allow aluminum into safety-critical structural components such as bumper systems, door intrusion beams, B-pillars, and other safety cage components. Now, Novelis claims the additional strength comes without sacrificing formability. The firm is a supplier to Ford for the F-150 program as well as for Range Rover and Jaguar for their XE. Now, the company's developed the current generation of high-volume aluminum sheet alloys, the familiar 6111, 6016, and 5754. So what does all this mean for automotive manufacturing? Well, the reduction or elimination of mixed metal construction in automotive bodies significantly reduces the fastening and assembly challenges in current mass production. Cadillac, for example, uses flow drive screws for significant portions of their small car platform. And although robotics has dramatically reduced the cost of mechanical fastening, the old axiom in the automotive industry that never use a screw where a spot weld will do is still true today. Even advanced structural adhesives work best when gluing together materials with similar coefficients of thermal expansion. And galvanic corrosion can never rear its head between bonded metals of the same material. Now, stamping aluminum sheet has never been easy, but the combination of Ford's successful experience with the F-150 program and modern simulation software really makes it work. Now, the software is key by reducing the number of iterations of tooling needed to accommodate springback and the unique flow properties of light alloys under pressure. It's now possible to spend $1 billion to launch a radical new vehicle platform, and much of that is in the tooling. The simulation software gives tooling designers the ability to specify new materials with confidence. Just as importantly, the cost reductions associated with simplified assembly should push aluminum construction down from larger, high-margin vehicles into the mainstream, and that'll put even more pressure on the steel community to downgauge even further with advanced high-strength alloys. Now, a major loser in this battle may in fact be carbon fiber composites. Composites are currently the ultimate in high strength and low weight, but even with automated layup and pre-preg sheet and strip, it's still expensive. With mass-producible all-aluminum structures, the weight advantage of carbon fiber is lower compared to steel structures. It's likely that for all but specialty luxury vehicle applications, composite construction will be delayed for years and may never go mainstream. So is there a long-range threat to aluminum auto manufacturing? When it comes, I suspect it will come from thermoplastics, not composites or HSS. Chrysler once developed a very interesting prototype called the CCV, or China Concept Vehicle, and the result was very impressive. The vehicle featured injection molded bodies that assembled like a kid's plastic model kit. I once examined one up close, and I agreed with many of the journalists present at the time that the car was highly marketable. Now, at that time, Chrysler didn't have the resources to take a risk on that scale, but I predict that eventually someone will do it, probably and ironically in China. In the meantime, aluminum is here to stay, and steel is in tough as greenhouse gas emissions targets drive the impetus to lighter and lighter vehicles. It's going to be interesting.